Okay, I'll start the class. Right. Let others join at the time. Okay. So you know what is S plane? Okay. That is a complex plane or a real plane? And what are the coordinates? Okay, since you will
Complex
not
plane.
answer and open your mouth. S is equal to sigma plus j omega. S complex plane. So sigma plus j omega. Sigma and omega are the two coordinates when it comes to your S plane. Okay. So sigma and omega are the coordinates. Real coordinate is sigma. Imaginary coordinate is omega. This is all for a S plane. Okay. Suppose if you consider a term f of s. Okay. This f of s. That is a function that is written as the ratio of two polynomials, and in the numerator you are having s minus z1, s minus z2 and s minus zm. So these will be the zeros of the numerator polynomial, and p1, p2 so on up to pn will be becoming poles of the denominator polynomial, and all are written in terms of s factor. So this will be a complex polynomial. But when it comes to f of s, okay, now I am talking about f of s. F of s is also a complex plane, but here the coordinates will be varying a little bit. The coordinates for your f of s plane will be u and jv. Okay, u plus jv. That's the difference. Both are different planes. While S plane you are having sigma and omega are the coordinates. F of S plane will be U and V as the coordinates. Now if you are considering these two planes, a point in S plane can be mapped on to a point in F of S plane. That is why you are discussing these two in comparison. Okay. And that is possible, that mapping is possible only when the points in S plane are analytic, not singular, analytic. Alright. So let us consider these two graphs. Alright. And this is a plane which is having the two coordinates sigma and j omega. So this plane is called as what plane? What is the name of the plane? It is there indicated on the slide itself. Sigma and j omega, the coordinates. What is the name of the plane?
S plane. S plane.
S plane. Okay. Now I want S plane, that contour is called as S plane contour. Okay. You know what is a contour, so I am not going deep into that concept. Now I want to map all these points onto another plane. What is the name of the plane?
S plane.
F of S. F of S
F of
plane.
S plane. F
F
of
of
S
S
plane.
F of
plane.
S plane.
Okay, F of S plane. But here this is also a complex plane, but the coordinates are changing a little bit. What are the coordinates now?
U and JV.
U and JV. So if I want to map all these points over to the other plane, there is one condition. The points in S plane all should be analytic. Okay, and it should not be a singular point. Do you know what is the meaning of analytic and not singular? Have you studied this concept in maths class or something?
No, ma'am.
Okay. So you understood the mapping concept? No. So what two planes are you going to map?
S and F of S.
S plane and F of S plane you are going to map both are complex planes, and the coordinates of S plane is sigma and omega. F of S plane, the coordinates are U and V. Now if you want to do this mapping, okay, if you want to do the mapping between these two planes, the points if you want to map, then there is a condition. The points should all be analytic and not singular. Okay, then only you can do the mapping. Now I'll tell you what is analytic. All the points in the S-plane should be having its function and derivatives. Okay. If functions and derivatives are existing, then those points will be called as what points? Those points will be called as your analytic points, and they will not be called as a singular point. Okay, but on the other hand, if no functions, no derivatives are existing, those points will be called as singular points. And example for singular points are origin, points on imaginary axis. All these points will be coming under singular point, singular category. Okay, singular category. So this is how the mapping will be done. Okay, simply whatever points you are having S plane, you are going to map on F of S plane only if the points are analytic and not singular. Analytic point means for that particular point, a function and its derivative must exist. Okay, suppose if that function and derivatives are not existing, then those points will be called as not analytic and no singular points. Example for singular point is whatever points you are having on origin, whatever points you are having for on imaginary axis, you will be calling those as singular points. Wait, there is a network interconnectivity. Wait, let it connect back. People are able to see my screen now.
No.
Are you able to see my screen? Only my voice is coming, but my screen is not visible. Again, the network got cut. Now you are able to see the screen?
No, ma'am.
No, ma'am.
My network connection is a little bit slow today. Okay. So problems will happen. So I will try to finish this up fast. Now all are able to see my screen, huh?
Ma'am, we can hear you, ma'am, but we cannot see your screen. Hear you.
I am presenting.
I don't know. Guys, is this only with me or others also cannot see?
Ma'am, no, ma'am, it's
Ma'am,
not
no, no,
visible.
we are not able to see the screen.
Okay, now?
No, ma'am.
Ma'am, only your name is coming in big.
Some problem.
Ma'am, rejoin, ma'am.
I used the maximum size of the call today. That's why maybe.
Ma'am, you try to rejoin one.
Because of so many. Okay, wait, I will connect Bluetooth and I will try. Wait. Now you are able to see
Yes.
my screen.
Yes, ma'am. Yes.
I don't know whether live board will load up. Connection is little bit slow. Okay. Okay, let's finish this up quickly, okay, before again some problem comes. But simple concept you understood, no, between S and F of S plane, how to map, what is the condition that should be present there? What condition? If
Ma'am,
you
it
want
should
to
be
map points
analytical.
and S plane to S plane, huh? Analytic, okay.
Analytic.
Functions and derivatives should exist and the point should not be singular. Singular point example is origin point and imaginary point. Okay, now we'll move on. Then next thing that you need to know about is what is the difference between points that are enclosed and points that are encircled, that you need to see. Okay, wait. The pages are taking a long time to load. Okay. Now another three sets of diagrams are there here. Okay, three diagrams. Now if you see to the first diagram, there are how many points there that are pointed here? Points in this diagram, how many points are there? First diagram. My markings are a little bit late to reach you, so I am telling first diagram. So what are the 2 points there? Come on, there are some points placed, no, and labels are also there. What are the 2 points?
Point A and point B.
Point A and point B. Okay, so which point you will tell that it is encircled by that path? A or B? This is the point, this is the circle or the path that is encircling the point A. Okay, in what direction? Clockwise or anti-clockwise?
Clockwise, man.
Clockwise. What about B point? B point, is it encircled by the same path or not encircled? Because it is outside the path or inside the path? See, A point, if you see, that is present inside the path that is traveling in the clockwise direction. So A will be called to be encircled, but B point is outside the path, so it will be said not encircled. Okay, this is about encirclement. Next diagram, if you see, means there are some shaded portions. So which point is shaded here, A or B? Second figure. Second figure, which point is shaded? A
A,
or B?
A, A.
A. So then that is said to be enclosed. Okay, that point is said to be enclosed. If you see to the third figure, which is present in the shaded path, third figure. Wait, let it come on the screen. Okay, this is the third figure. So here if you see which point is present in the shaded path, shaded region.
B.
B. So B is said to be enclosed. So what do you mean by enclosure and encircled? Have you understood? There are two things, encirclement and enclosure. Okay, encirclement means if you are having a path, that point should be present inside the path and not outside. Okay, enclosed means it should be located in the shaded portion to the right of the path. Okay, that way there is a difference between encirclement and enclosure. Next we will move on to another concept which will lead to the principle of argument that might be asked in a 4-mark question. The page that it loads. Okay, this page is shown there. So in the first diagram, how many poles are there and how many zeros are there? First diagram, tell me. How many poles, how many zeros are there in a plane?
Zero pole, two, yes, ma'am. Pole zero.
Zero pole is correct, but here you are having
Two
1
zeros.
0, here you are having 1 0, both are complex zeros. You can see for
Two zeros,
yourself,
ma'am.
the zeros are -1 minus j2, -1 plus j2. So here you are having complex zeros that are located in what plane?
S plane.
S plane, okay. And in the other side you are having one more plane. What is the other plane? There are coordinates u, j, v, that graph. What is the name of that plane?
F of S plane.
F of S plane.
F S plane. So there you are having some encirclements. So the nature of the encirclement is clockwise or anti-clockwise?
Clockwise.
Clockwise. How many encirclements are there? The clockwise encirclements are how many in number?
1.
1 now.
4.
4 up 2. See, this is one encirclement and this is the second encirclement. So 2 number of encirclements are there. So how many zeros were there in the S plane?
2.
2 zeros were there in the S plane. Correspondingly, you are having how many encirclements in F of S plane?
2.
2. Yes.
2. And the nature of the encirclement is clockwise or anti-clockwise?
Clockwise.
Clockwise. You remember this concept? And one more thing you need to know, the encirclement here is 0. Okay, at origin you are going to consider the encirclement. Every time for F of S plane, at origin you have to consider the encirclement. Okay, I have made on blue mark now. Around that only the encirclement is there. Okay, if you see to the second diagram, what can you observe? How many poles are there in the S plane? Cross marks are usually resembling your poles. So how many poles are located on the S plane?
2 poles, ma'am.
2 poles. So you are having one cross mark here, you are having one cross mark here. So 2 poles are there. If you see to the F of S plane, how many encirclements around origin? Encirclements are to be considered with respect to origin. So origin is encircled how many times in what direction?
2 times, ma'am.
2 times. How many you have told me? In what direction it is encircling 0? Clockwise or anti-clockwise?
Anti-clockwise.
Anti-clockwise.
Clockwise.
Okay, clockwise or anti-clockwise?
Yes, ma'am.
Okay, next, third diagram. Third diagram, how many poles are there? How many encirclements are you observing in F of S plane? Let it load. I have zoomed. Let it load. Third diagram. How many poles and zeros are there in your S plane, and how many encirclements are you observing in f of S plane? Quickly see. Otherwise, you won't be having time to solve problems. One problem at least I have to solve because it will come in a CT2, and I am not having any more classes to teach that. So how many zeros and how many poles are you having in S plane?
1 0 2 poles.
Yes, 1 0 2 poles. 1 0 2 poles. 1 0 2 poles you are having. So how many encirclements are you having in a 0 origin in f of S plane? And what is the nature of the encirclement? Anti-clockwise or clockwise?
Anti-clockwise, double rotation, ma'am.
Double rotation, no. Single only, no.
Means showing 2 arrows.
One time. One time only, okay. Earlier cases only 2 encirclements, here only 1 encirclement. So if you can finally observe, here in the first diagram, you were having number of zeros is equivalent to 1. And the number of encirclements that you are having, number of zeros was 2, the number of encirclements, let it be represented by letter N, that is equivalent to 2, and the nature of the encirclement was clockwise. Okay. And if the number of the poles represented by P is 2, then you are having again 2 number of encirclements, but now in anti-clockwise. Okay, that we have observed again. Third case, if you see, means the difference. What is the difference between P and 0? P is 2 and 0 is 1. So the difference will be equivalent to the number of encirclements. So N is equivalent to P minus Z. What is N now?
1.
1. So that many number of times of encirclement only will be present, plus which is dominant. The number of poles is dominant or number of zeros is dominant?
Poles, ma'am.
Poles.
Number of
So,
poles.
yes, poles are there means clockwise or anti-clockwise you are observing?
Clockwise.
Clockwise is for 0. Poles it is anti-clockwise. So one time anti-clockwise encirclement you are watching. Okay, that's all. That is being referred by this. Now remaining things we will discuss now. If you see to this diagram, wait, let it load. Okay, this diagram if you see, how many number of poles are there, what is P and what is 0? Zeros are 2 in number, small crosses. The poles are 1. So what is the difference? Difference is the number of encirclements. So Z is greater or poles is greater?
Zeros.
Zeros are dominant. So 0 minus pole is 2 minus 1. That is the number of encirclements. So how many encirclements are you having around origin?
1.
1. So the nature of the encirclement will be clockwise or anti-clockwise? Because zeros are dominant,
Clockwise.
nature will be clockwise. Okay, that is the case. And if you see to the next diagram, how many number of poles and how many number of zeros are you observing?
2.
P is equal to 2 and Z is equal to 2. So N will be equivalent to 2 minus 2, that is equivalent to 0. That will be the number of encirclement. But okay, this is your 0 origin point. So how many encirclements are present around the origin? Is there any encirclement around the origin or not?
No, ma'am.
No. Okay,
No,
so
ma'am.
no encirclement. Okay, no encirclement. And one more case, if you see here, means the poles and zeros are located in the last case. Let it load. Okay, the poles and zeros are located, but they are not being enclosed by the S-plane contour. Okay, S-plane contour is over here, but the poles and zeros are located in a different position outside. Okay, so those are not enclosed. So if this is the case, again you refer to the f of S-plane contour. Does it encircle origin or no encirclement? This is origin. Does it encircle it or doesn't encircle? Origin point is, does it encircle? Okay, so these are the observations made because of the presence of the poles and zeros in your S-plane and the contour that you are drawing in f of S-plane. Based upon that only you will define one argument that is called as principle of argument. Let us move on to that principle of argument. Now there is one relationship. What is that relationship? N is equal to what? Resume in a better way. Okay, wait. N is given by the difference between what two? Already I have told you what.
Poles and zeros.
Yes, poles and zeros. P represents your number of poles, Z represents your number of zeros, N will be representing your number of encirclement around the origin point in your f of S plane. Okay, now it is visible for you. What is the formula for N?
P minus Z.
Yes, ma'am.
P minus Z. N is representing number of encirclements around origin. P is representing your number of poles. Z is representing your number of zeros. So, number of encirclements is given by the difference between poles and zeros. That is a formula. There are three cases that you have seen from the graphs. That is mapping of the poles and zeros located in S-plane to the encirclement of 0 in the f of S-plane. Based upon the 3 points you will be having, that is called as principle of argument. Okay, this might be asked in 2-mark question. What is principle of argument? And that principle of argument is based upon that boldened 3 statements that we are having in the slide. Suppose if N is positive, what is the observation that you have seen? Suppose if N is negative, N is 0, then what is the observation that you have seen from the graphs? N is positive means what happens? The number of encirclement of origin in the f of S-plane contour will be anti-clockwise or clockwise? All is written over there in the screen. See, the f of S-plane contour will be encircling origin clockwise or anti-clockwise if N is positive?
Anti-clockwise, ma'am.
Anti-clockwise. Because in that case, the presence of the poles will be dominant, so P will be positive, Z will be lesser. So in this case, the number of encirclement will also be a positive one. So the number of encirclement of origin in the f of S-plane will be anti-clockwise. Suppose if N is negative means zeros are dominant. Zeros are present means the nature of the encirclement will be clockwise. So that is given by the 3rd point. Suppose if both are equal, if poles and zeros are equal, then N will also be 0. Then what will be the nature of the encirclement in the f of S-plane of origin? Will there be any encirclement or no encirclement? No encirclement. Okay. So that is how you are going to relate the two contours, S-plane contour and f of S-plane contours. In S-plane you will be making sure how many poles and zeros are enclosed. Okay, depending upon that you will observe how many encirclements are present around the origin in f of S-plane. Okay, and next we will move on to Nyquist stability criterion. Directly I will jump to the criterion. Okay, wait. Now another thing, we have seen only 2 planes now so far. One is your S-plane you have discussed, and the next thing is your f of S-plane you have discussed. Okay. Now f of S is given by 1 plus g of S into h of S, or g of S into h of S. Generally f of S is given by g of S into h of S, not 1 plus g of S into h of S, but simply g of S into h of S. Now you know what is a characteristic equation general representation. So what is a characteristic equation? f of s is simply g of s into h of s. Okay. Now, if you want to write the characteristic equation, that will be the denominator polynomial, that is usually given by 1 plus g of s into h of s only, is equal to 0. Now, in this g of s into h of s, you will be replacing it as f of s. Okay. Now, alright. Now, based upon this only, one relationship is there. You can check it out for yourself. There is one relationship that is shown, that is g of s into h of s. Okay, this relationship that you are seeing here, this is showing that g of s, h of s is also equivalent to what plane? Finally, this can also be written as g of s into h of s plus 1 minus 1 if you give. Then this 1 plus g of s into h of s, I am substituting it as f of s minus 1. Okay, now comes from s plane, then f of s plane, then now we are moving to f of s minus 1 plane, which is equivalent to g of s into h of s plane. Okay, so the third mapping you are going to consider now. Let it load, okay, it's delaying a little bit. Just remember S plane, then you are having f of s plane, then that f of s plane is now will be converted to f of s minus 1 plane. That f of s minus 1 plane is nothing but g of s into h of s plane, that's all. Okay. Okay. Again I am telling you, from S plane we have learned how to map it on f of S plane. Now we are going to change it a little bit. We are going to change the f of S plane to f of S minus 1 plane. That f of s minus 1 plane is nothing but g of s into h of s plane, from which you will be discussing system stability. And the corresponding f of s minus 1 will be called as Nyquist quantum. And there is one diagram you can see here in the slide. Are you able to see? Yes or no?
Yes, ma'am.
Okay,
Yes,
so
yes,
again I
ma'am.
am telling you, okay, we have started off with S plane, and the points are to be mapped on f of s plane. Now we are changing the f of s plane a little bit. You are changing it to f of s minus 1 plane, and that is equivalent to g of s into h of s. And you know, by discussing the root location on g of s into h of s, you will be discussing stability. That is what you are going to do here also. Okay, and there are two contacts that are present in the graph. What are the two contacts that you are having? Now you understood, I am hoping. We have started out with S plane. The points on S plane were first mapped on to f of S plane, from which you derived the principle of argument. Then that plane is changed a little bit by joining on 1 there. So that becomes your f of s minus 1 plane. That is also g of s into h of s plane. Now here afterwards, For Nyquist stability criterion, you are not going to consider f of s plane. You are going to consider only f of s minus 1. That is g of s into h of s plane only. Okay, because the roots of this parameter only decides stability. That is, the location of the pole should not be in the right half. Okay, same way you are going to discuss stability here. That's why you have chosen not f of s plane but f of s minus 1 plane. Okay. Now if you see to the two graphs, this curve, that is called as what contour? That one that is highlighted, that is labeled as what contour?
Contour of f of s.
F of s. So that is encircling what point? This point. Usually we will relate the location of poles and zeros in S plane to the encirclement of what point by f of s contour. The dot point is showing what point?
Origin.
Origin. Okay, that is when it comes to relating S plane points to f of S plane contour. But now they have drawn one more contour. This one. That is named as what contour now? The other one.
F of s minus 1.
F of s minus 1, that is also equivalent to g of s into h of s. Okay, and here when it comes to discussing contour of f of s minus 1, what encirclement you need to consider? Origin or another point? They have marked by an arrow, no?
Origin will shift towards left side.
No, I have circled one point, minus 1 plus
0 j.
yes, minus 1 plus j0, minus 1 point only here afterwards you have to consider. You have to relate the encirclement of minus 1 plus j0 point only to discuss system stability. Understood this concept now? Yes or no?
Yes,
Shall we
ma'am.
proceed?
Yes, yes, ma'am.
Okay.
Yes, ma'am.
So f of s means encirclement of 0 we are relating. But when it comes to f of s minus 1 contour, now we need to discuss what point encirclement. Hereafter we need to discuss only minus 1 plus j0 point encirclement only. Okay. Now that is the thing that I want to describe. That is important concept. See this contour that I am zooming up, that contour is called as Nyquist contour. Okay, sometimes they will ask you this question in 2 mark, what is a Nyquist contour? So how can you define this Nyquist contour? What are the various segments that it has? You tell me. The segments are this is called as your Nyquist contour. Okay, that is drawn on what plane? Nyquist contour.
S plane.
S plane. Okay. Now there are 3 segments for it. C1, C2, C3. C1, C2, C3 are the 3 segments that it has. Okay. Now C1 is along the imaginary axis or not along the imaginary axis? Which one is along the imaginary axis out of these 3?
C1, C3.
C1, C3 are along the imaginary axis. Okay, these are along the imaginary axis. And if you see to C1, it is starting from what value of omega to what value of omega?
Minus
0 to
Starting
0
from
to
0 to
0 to infinity. If it comes to C3 means it is starting over from minus infinity to 0. What about that C2 segment? What can you say about the C2 segment? It covers up its
infinity to
radius. Yes, it is covering up the entire right half of the S plane or left half of the S plane.
right half. Ma'am.
right half of the S plane, and the radius is tending to what value? They have given radius tending to what value?
Infinity, ma'am.
Infinity. So it covers the entire half of the right half of the S plane, and that is an arc, okay, of infinite radius. So these will be the segments that will be present in what contour is this? What is the name of this contour? Nyquist contour. So your first step in solving problems are, first step is you draw the Nyquist contour. Okay, in S plane. Plus you need to remember that this Nyquist contour should not pass through singular points. So what are the various singular points that you are having? What are singular points, Ma? Initially I told you what are singular points. Now what are singular points? Those points are not analytic points. Functions and derivatives will not exist. So I have given some examples for singular points now. Okay. I am showing some diagram. 3 diagrams are there. The first one is your normal contour. Wait, let it load. There are 3 diagrams you can see. Yes or no?
Yes, ma'am.
Okay, the first is the usual Nyquist contour. This one is your usual Nyquist contour. Okay, but the second one, there is a pole at what point? There is a pole at origin. So does the Nyquist contour pass through the origin or it is bypassing?
Passing through the origin.
Passing through the origin. No. Does it pass through the origin?
Oh, sorry,
No.
ma'am. Sorry.
It is bypassing. It is bypassing the origin.
Yes, ma'am.
Okay, it's bypassing the origin. It doesn't pass through that origin point. It is bypassing. Like that only you have to draw the Nyquist contour when it comes to location of poles in origin. Now third diagram, what are the nature of the poles that are located? Third diagram, where are the poles being located? There are 3 poles indicated in the third diagram. One pole is located at origin. The remaining 2 poles are located on imaginary axis. Again, does the Nyquist contour pass through the points or it is bypassing?
Bypassing, ma'am.
It is bypassing. It does not pass through this point. It takes a detour. Okay, it doesn't pass through those points. So like this only you have to draw the Nyquist contour. Nyquist contour will not pass through the singular points. Singular points are points that are poles located at imaginary axis or imaginary origin. Those points should be taken a detour, bypassed. Okay, that is how you have to draw the Nyquist contour. That finishes off. And one final thing, Nyquist stability criteria we will discuss. There are 3 points. So first point says no encirclement of -1 plus j0. I told you here afterwards we will not discuss encirclement of 0. Here afterwards we will be discussing encirclement of what point?
And -1
-1 plus j0. No encirclement of -1 plus j0 means no poles are located in. Okay, if there are no encirclement of this point and if no poles are located on right half, then the system will be what? System will be stable. Okay, no encirclement. If n is equal to 0, that is the case, then P is equal to 0. That is no poles are located on the right half of the plane, then the system will be considered to be what? Stable or unstable? Stable or unstable? You can read the statements, no?
Unstable.
Unstable means poles are located on right half means the system is unstable. If no poles are located on right half means then the system will be stable only, no? You have studied this in location of roots, yes or no?
Yes, ma'am.
Yes, ma'am.
Okay, so what will you infer? First case, no encirclement of -1 plus J0 point means first you have to check whether the poles are located in right half. Any one pole is located in right half. If no poles are located in right half, then the system will be stable or unstable.
Stable, ma'am.
Stable only. N is equal to P means stable. That is poles. No poles are located on right half. Second case, anti-clockwise encirclement of -1 plus J0. Okay, anti-clockwise encirclement means you have to check out how many number of poles are there, and if the number of poles are equal to number of anti-clockwise encirclements. Okay, all right. Okay, system is stable if the number of the anti-clockwise encirclement is same as the number of the poles located in right half. Okay, then the system will be stable. Suppose if both are mismatching, then the system will be unstable. Next case, last case is whenever you are observing clockwise encirclement, then always the system will be unstable. Okay, that is called as Nyquist stability criterion. Okay, in simple words, I will tell you. The thing is now N is equal to P. Okay, N is equal to P. Now it is changed to N is equal to P. So you know what is N. N represents what? The number of encirclements of point -1 plus J0. Okay, and P represents your poles located on right half of the S plane. Okay, alright. If both are equal means always the system will be stable only. Okay, suppose if N is equal to 0 and P is equal to 0, then system is stable or unstable. No encirclement of -1 plus J0, number of poles located in right half is also 0, then the system is stable or unstable? Stable, otherwise it is not stable. Suppose if you are having two number of poles located in right half, accordingly if you are having number of encirclements is also number 2 in anti-clockwise direction, then the system is stable or unstable?
Stable, ma'am.
Stable. Okay. Third case, suppose if you are having clockwise encirclement. Clockwise encirclement means directly you should tell that the system is unstable only. Understood? Yes or no?
Yes, ma'am.
So
Yes,
what is
ma'am.
the name of this criterion? This criterion is called as what criterion? What is the name of the criterion? Nyquist?
Stability.
Nyquist stability criterion. Again, one more time, last time you tell me, suppose if no encirclement of -1 plus 0 is there, then accordingly there should be no poles located on the right half. If that condition is satisfied, system is stable or unstable? Others should also tell me the answer. This concept is important. Whenever there is clockwise means system is always unstable. Anti-clockwise means you have to check how many number of encirclements. Then the same way you have to check out how many number of poles. If both are matching means system is stable, otherwise not stable. If no encirclements are there, no poles should be located in right half. N equal to P is a condition now. Okay. Now move on to the problem. Okay. So they have given one problem. You are supposed to draw the Nyquist plot for the system. Let it load. Okay, so here is the problem. Draw the Nyquist plot for the system whose open loop transfer function is given by what function? What is the function? G of s into h of s is equal to what? K divided by s into s plus 2 into s plus 10. So this is your minimum phase transfer function. Why this is a minimum phase transfer function is because only poles are there. What are the various poles and how many number? How many poles are there and How many number? There are totally 3 poles.
3 poles.
One is located
0,
at
-2,
origin,
-2.
and one is located at 0, one is located at -2, and the other one is located at -10. So the pole that is located at the origin is a singular point or a not singular point? Come on, is there any pole located in origin as per this problem, yes or no?
Yes, ma'am. Pole is.
Yes, so that is a singular point or a non-singular point? That is singular point or non-singular point? That is my question. Based upon that only first step because counter you draw. So, 0 is a singular point or a non-singular point? Whenever you are having poles on origin or imaginary axis, those 2 points will be called as what point? Those points are called as singular points. So while drawing Nyquist contour, you have to pass through the point or you have to bypass it?
Bypass.
Bypass. So first step is you are drawing this contour. What is the name of the contour? This contour that I am showing, that contour is called as what contour?
Nyquist contour.
That contour you have to draw. So as per this problem, there is a pole that is located on origin. So that is a singular point. So while you are drawing a Nyquist plot, take a detour like this. It should not pass through that point. Okay, like that only you have to draw the Nyquist contour. That is mandatory. So if you are doing that, now we will have an additional segment. So what are the various segments that you are having? Marked by C1, C2, C3, C4. What are the various segments that you are having for the Nyquist contour? C1 is a segment moving along what axis? Real axis or imaginary axis? This segment.
Imaginary axis.
Imaginary
Imaginary.
axis. Okay, so it is traveling from what value of omega to what value of omega?
0 to infinity.
0 to infinity. That is segment number 1. Okay, next. Second segment. Second segment is your C2. So C2, what can you say about C2? It is a big arc of what radius? What is the radius of that? Infinity. Okay, and it will cover the entire right half or left half of S plane?
Right half.
Right half. Okay, that is your segment number 2. Third segment. What is your third segment? Third segment is along what axis again? In purple color that I am drawing, it is directed along what axis? Imaginary axis. What is the starting point? Minus infinity to 0 it travels along. Then finally the red color marking, okay, that is the additional segment because of the bypass, that is C4 segment, that is again an arc, but what is the radius of that arc now?
0.
0. Okay, so this contour is called as what contour? What is the name of the contour? Nyquist contour. Like this you have to draw a Nyquist contour for the given problem first step. Okay, understood the first step? What is your first step? What is your first step? You have to draw what contour as your first step?
You have to draw the Nyquist contour.
Nyquist contour. Suppose if you are having a pole at origin or pole on imaginary axis, then you have to bypass around it and you have to draw. Otherwise, you have to completely follow the original Nyquist contour. Okay, that finished your first step. Now, next thing is, you have to write down the time constant representation. This is in pole 0 format. So you will be turning it into time constant. So in this formula, you will take out 2 and 10 out from the equation. Then you will rewrite it as shown here and you will bring it to time constant form. That is your next step. Always I tell you, first you have to observe the given equation. If it is in pole 0 form, you have to convert that into time constant. That is into 1 plus st format you have to bring. Okay, that is also done. Okay, this is your time constant representation. Now, the next thing that you need to do is, before discussing system stability, there are totally how many segments in the Nyquist counter?
3.
3 or 4? C1, C2, C3, C4, na?
4.
4.
Four segments. So you have to consider each and every segment, and that each segment should be mapped onto what plane now? Mapping from S plane should be done to what plane?
F of S.
This should be mapped onto f of s minus 1 plane, where the encirclement of the point minus 1 plus j0 will be considered for discussing system stability. Okay, so you have to consider each and every section separately. So there are 4 segments, so 4 mappings you have to do. So first segment is what segment? This is your first segment, that is your line segment along imaginary axis, where omega is varying from 0 to infinity. So this map should be always polar plot. Okay, locus of polar plot. Okay, and in some or the other way you need to draw the rough plot. So this is a system that is of minimum phase. So you know what is the type and what is the order of the system. So what is the type and what is the order of the system?
Type 3.
Type 3 up.
Type 1, order 3.
Sorry, type 1, order 3.
Type 1, order 3.
Type is 1, order is 3.
3. Yes. Type 1, order 3.
So type is indicating start, order is indicating end. So in which quadrant it will start and which quadrant it will end, that will be decided by the system. So remember this thing, type 1 and order 3. Okay, now next I will move on to the next page. So this is the segment, first segment. Wait, let it load. Okay, this segment that I am showing, first I will map onto what plane now I am going to map? What is the plane that I am going to map?
S plane.
S plane.
F of S minus.
No, S plane segment
No,
is
ma'am,
mapped
F of S
onto,
minus 1. F of S minus 1.
mapped onto what plane? This plane.
G of S, H
G of S into H of S plane, that is F of S minus 1 plane.
1 plane.
Okay, so this quadrant number 1 is 0 order. Right. Type first, let me discuss. This is type 0, this is type 1, type 2, type 3. So what type system is there? Our system, that problem given statement says it is of what type? What type? Type?
Type 1. 1.
Type 1. So which quadrant it is going to start?
Third quadrant.
Third quadrant. This is type 1 quadrant. So order 2 and order 3. So yours is order 3 system. So where the plot is going to end? Termination is decided second quadrant, so it is ending at second quadrant. Okay, but you don't know where it crosses this. Okay, in order to find out the crossing point, there is a particular procedure. You have to substitute omega is equal to 0, omega is equal to infinity in the magnitude and phase angle, and you can find out what point you are having. That is ways. Different methods are possible for exactly determining the crossing on the real axis. That is very, very important. Okay, here let us see what concept they have discussed. Okay, but you understood the type and order, start and end, no? Yes or no?
Yes, ma'am.
Okay, so this system is type 1 order 3 system. Okay, generally this system is having only poles, so you can use type and order to determine where the plot is going to start and where it is going to end. So based upon that, this is your type 1 quadrant and this is your order 3 quadrant. So the plot is starting over here and it is ending here roughly. but you don't know where it is crossing exactly. So you have to follow some procedure to find out where that crossing point is. So let's discuss that. So this is your time constant representation, for which I will be substituting S is equal to j omega. Okay, and I will be separating up the real part and imaginary part. So what is the imaginary part from this equation? What is the imaginary part from this equation? The last equation, 0.05 k divided by minus 0.6 omega squared plus j omega 1 minus 0.05 omega squared is there, no? So what is the imaginary part there?
1 minus 0.05
One,
omega.
yes.
into 1 minus.
So this one is your imaginary part. So that imaginary part you have to equate it to, okay, that's shown by the arrow mark, no? That is your imaginary part. So that imaginary part you are going to consider. What is the real part also you make a note. The real part is 0.05 k divided by minus 0.6 omega squared. Okay, that you will equate it to 0 and you will be finding out omega PC, because it is 180 degree axis, no? So here what they have done, that imaginary part they have equated to 0, yes or no? This imaginary part
Yes,
they have
ma'am.
equated to 0 because that is the negative real axis minus 180 degree. This frequency will be called as phase crossover frequency. So they are finding out phase crossover frequency. What is the value of that omega value? All is in the slide, you know. What is the value of the phase crossover frequency? 4.472 radian per second. So then comes your real part. Okay, so what is the real part that you are having? It is also there, no? 0.05 k divided by
minus 0.6 omega.
I'll show it again. It takes a long time to give shift between pages. Okay, so the same equation, this is your real part, 0.05 k divided by minus 0.6 omega squared. In this omega, I will be substituting omega PC, that is 4.472. Okay. Alright, and then I will be finding out that crossing point. That will be my crossing point. Like we have did it in root locus, no, same concept here also. Understood? Yes or no?
Yes, ma'am.
Okay. So that they have equated, and what is the point that they have found out as a result? Minus 0.0041
7k.
7k. So that is your crossing point. Okay, that is your crossing point. That you will mark it here. Okay, minus 0.004117k. Understood the first mapping? What are you doing first? How many segments are there as per the Nyquist contour? What are the segments that are present in the Nyquist contour?
4 segments.
4 segments. So what is the first segment? This is your first segment, that is your imaginary line segment, that is originating from omega is equal to 0 to omega is equal to infinity. Then you have to map on to f of s minus 1, that is g of s into h of s contour. So the map will be always a polar plot. That's why the polar plots are also called as Nyquist plots. Somebody was asking me some doubt earlier, so this is the reason why both are called in the same fashion. Okay, so the map for line segments are always polar plots. Okay, if it is a minimum phase function, means roughly you can draw the polar plot. By knowing the type and order, you can frame out where the plot is going to start and end. That you already know. But the important thing is you need to find out where it crosses here at the real axis. For that you are equating the imaginary part to 0 and you are finding out omega. You are substituting that omega value in the real part and you are finding out the crossing point. That crossing point is obtained to be what value? Minus 0.0417K. Okay, so this finishes off your first map. Okay, let us proceed with the second segment. What is your second segment? Second segment C2. Come on, let's finish this quickly. What is your second segment as per the Nyquist quantum?
C2, man.
C2. What do you know about C2? That is a line segment or an arc?
Arc with radius
Arc.
infinity.
Okay, this is your second segment. That is your arc whose radius is tending to what value?
Infinity, man.
Sorry,
Infinity. Infinity. And what is the angle direction in which it travels? You refer to the diagram and tell me. You know from polar plot this is 0 degree. Then minus 90, minus 180, minus 270 will be in clockwise or anti-clockwise? 0, minus 90, minus 180, okay, this one is minus 270. All will be in clockwise, negative angles they are taken. Positive angles, where will you take? This will be pi by 2 and this will be again plus 180 and this will be plus 270. Okay, so one more thing you have to know is this is plus pi by 2, this is minus pi by 2. So if you see the contour, the contour is taking this direction. So what is the angle arrangement? It is ranging from pi by 2 to minus pi by 2. Like that you have to consider. Understood why I am telling pi by 2 to minus pi by 2 travel?
Yes, ma'am.
Okay, so this is the nature of the arc. Okay. R is radius, the angle arrangement is, it is travelling from plus pi by 2 to minus pi by 2. Remember the radius is infinity. The general representation for that is S is equal to limit R tending to infinity R into e power j theta, where R represents your magnitude and theta represents your phase angle. So you know what is R. R tends to what value and theta tends to what value? Tell me. Just now I told you, R is radius. Radius is tending to infinity or 0?
Tending to infinity.
Radius is infinity. What about theta?
Pi by 2 to minus
Theta. Pi by 2 to minus pi by 2. That you have to substitute in the formula. For that purpose only I am telling you this thing. Okay, let's move on to the given transfer function. Okay, this is of time constant form. So if you are comparing this 0.5 s and 1, which you can neglect, which is bigger? In all places of s you are going to substitute this limit where r tends to infinity. So if you compare 1 and 0.5 s and if you compare 1 and 0.1 s, which you can easily eliminate, which will be greater?
And 0.5 into s will be great.
Yes, so you can eliminate this one term, you can eliminate from the equation. Okay, then you can rewrite it again like this. Okay, 0.05k divided by s into 0.5s into 0.1s. If you simplify that, finally the equation will be becoming k divided by s cubed. And in that s, you are going to apply the limits. So I have eliminated the one. Okay, and I am rewriting the equation. Finally, k divided by s cube will be the simplified term. So in place of S, what am I substituting now? That limit. What limit? Limit r tending to infinity r into j power theta to the power 3. This is my S. Okay, so in place of S, I am substituting that limit. So you know what is the radius. Radius is what value? Radius is taking what value? Infinity. So k divided by infinity, what is the value? Anything divided by infinity, what is the answer?
0.
0. So 0 is the magnitude. Now the angle is ranging from pi by 2 to minus pi by 2. Okay, so to the power 3. So what will be the angle now? 3 theta. Okay, so now for the map, what will be the angle? Now theta is converted to 3 theta. So 3 pi by 2 minus, because it is the numerator, if you are taking it up, it will become minus 3 pi by 2 and plus 3 pi by 2. That is for the map. This is for the map and this is for the original segment. Understood? Now I am going to draw the map. I am trying to rush off a little bit because time is not there. So this is a map that I am having. Now what is the radius for that map and what is the angle for that map? You have to tell me. For this original segment, the radius is infinity. For the map, what will be the radius? By calculation also, just now I told you, k divided by infinity, if you are putting what is the magnitude of the map?
And radius equals to 0 and tends to 0.
Radius? Radius is?
Tends to 0. Man.
0. Because you are
0,
having
0.
k divided by infinity, the radius is 0. It will be a small circle. Around the origin only it will be present. Even though it is drawn little bigger here, it will not be drawn bigger. It will be a small circle around the origin point. Okay. Then, if you see to the angle of the original segment, here it is traveling from pi by 2 to minus pi by 2. But what about the map? It is 3 theta minus 3 theta. So what will be the range of the map? What is 3 pi by 2?
272.
272.
270.
Yes, it is traveling from minus 270 to plus 270. So where will you have minus 270? You know, just now I have drawn 0. Negative axis, negative angles means in clockwise you have to take. Positive angles means in anti-clockwise you have to take. Let me rub this little bit. Okay. So here it is 0. Here it is minus 90, here it is minus 180, this point will be minus 270. So it takes some time for that marking to load. Wait till it loads. So it travels from minus 270 to plus 270. Because if it is from 90 to 90 means 1/2 you will get. But it is 270 to 270. That's why double encirclement are there. Okay? I hope you understood because the markings are taking a long time to show off. So I am telling it in words.
Ma'am,
You are having lab, huh?
Ma'am, Sridhar sir has texted in the group.
Yes, ma'am.
Okay, go. Okay, but the other things you study. Okay, if this problem comes means you self-learn. Alright, I will guarantee that this problem doesn't come. Okay, the third image, it will be a
Ma'am, you
mirror
told me that
image.
you are making the question paper, ma'am. You don't give this problem.
One set only I will take. Why? Both sets I will be taking. Another person is taking another set. What if that sir gives you?
Ma'am,
Okay,
you tell
so
that
you
teacher.
study. Oh, let me see. Okay, so third segment will be map. All can leave, I think so. Okay, Let's discuss this in some other class or lab class. At the end, I will try to teach. Okay. Now all can leave, ma.
Thank you.